Today we're at the AECB conference and we are learning all about retrofit.
We've got 160 people here.
So it can be a real melting pot of shared ideas.
New technologies, new methodologies.
Help encourage each other.
Some amazing policy changes.
It's about learning. It's for people that really care and want to really decarbonise.
We're going to dive into an AECB retrofit, one that's achieved standard. It's a big building up in Scotland, one of the biggest AECB projects in the UK. And we're very fortunate to have Ed with us, who's going to introduce himself, obviously, and talk to you about that. So please welcome Ed. Thank you.
Talk about tough act to follow, Rachel. Goodness me. And Colin, this is a retrofit of a retrofit that failed, so that's a good segue there. So I am Ed Dymock. I am an architect practicing in Glasgow with PDP. I'm a Passivhaus Designer and our studio sustainability champion. And I'm here to tell you about the retrofit of retrofit. So this is Prospecthill Court, one of 3 towers. Social housing, there's so much to be gained, so much to be gained. Retrofit of social housing, that's 23% housing stock in Scotland, 1 in 4 housing. If we can tackle retrofit of social housing, in particular high-rise buildings, we change the destiny of these buildings, but potentially using, targets like the AECB's carbon light, we changed the destiny of their tenants as well. This is what gets us out of bed in the morning, isn't it? This is the potential issue. I'm not from Swindon. I'm actually from Cornwall. I practice in Glasgow, so this is my centre of gravity here, maybe. I need you guys to care about this project as much as I do, so I'm going to go into a bit of a deep dive into Greenock's social housing history. So like many towns, Greenock's or the social housing, the housing history of a place is connected deeply, directly to its economic history. And the economic history begins with place and topography. So Greenock is sat on the southern bank of the Clyde. It was once the head of the navigable river, so home to a fishing community. The fishing community were pretty good at fishing, so they needed to feed a growing population. They needed to build more fishing boats. Greenock became boat builders and ultimately ship builders. The town thrived. You can see the industry, the thriving industry clinging to the flatlands around the coast. There's the future location of Prospecthill Court highlighted there. You can see the property thinning dramatically. That's due to that steep topography at the back of the town. A few of the fine buildings built by the Victorians remain, but largely Greenock is a place of deprivation, high fuel poverty, high levels of worklessness. And that really isn't a new feature. That is a feature that was created by the immigration from its initial success. So that kind of cheek by jowl relationship really created some of those poor housing conditions that people in Greenock have kind of always suffered, actually. It wasn't just shipbuilding. Greenock was actually part of that slave trade triangle, taking blacks from Africa to the Caribbean, bringing sugar from the Caribbean to the British Empire. And I think understanding these kind of sort of social histories of a town just helps everyone get behind the sort of mission statement that we can actually improve people's lives with what we're doing. Greenock was home to 14 sugar refineries at its peak, and the largest sugar refining hub in the British Empire outside of London. Names of local magnates like Abram Lyle will be familiar. Even as I flew into City Airport this week, you can see that brand name still all over London as well. Dredging of the Clyde meant a lot of Greenock's shipbuilding industry moved to Glasgow, and the town's economic successes started to wane. So they looked to replace those industries, and actually high tech, this is IBM's HQ back in the 70s, super semiconductor as well. There was a real political push to get new industry into Greenock. And for a while that really worked. So there was thousands of people employed in these, in Silicon Glen, as it became known. But in the 2010s, these industries also left the town. We tried to replace it with cruise ship industry. Unfortunately, the cruise ship tourists tend to berth in Greenock and then get on a bus and head to the distilleries and to the shopping in Glasgow. For me, it actually creates a little bit of an uncomfortable relationship between the wealth, sort of apparent wealth and pollution of the ships and the situation in Greenock. Because that situation, that housing situation, has always been bad. Immigration from Ireland and from the Scottish Highlands during its heyday meant housing conditions were terrible. In a 1919 survey demanded by the government, Greenock identified that 27,000 residents needed improved or new homes. To compare that, to give that some context, Greenock has a population today of about 42,000. So this isn't a new issue. Greenock's always needed new housing. Wars don't help. We look around the world and we can see housing problems being created by our own actions, and that was certainly the case for the Second World War as well. The Blitz of the 7th of May, 1941, killed 250 people in Greenock and lots of damage to its housing stock as well. Greenock was actually, unluckily, only one of two Scottish towns bombed in the war, the other being Clydebank, the other shipbuilding hub. I was actually really fascinated to find this picture of Baxter Street because the tenant liaison for our project noted that actually Baxter Street are now River Clyde Homes properties looked after and cared for by our client, Prospecthill Court. I think that's a really lovely message, actually, that we can find direct relationships between Greenock's history and the renewal and care that River Clyde Homes have for their 6,000 properties in Greenock. So what was the solution to Greenock's housing problem? Well, like, again, many towns across the UK, it looked to build quickly and build cheaply. So post-war innovation included importing kit houses from the United States, from Scandinavia, and there are a few of those actually still around, but most failed. Most weren't up to the damp and wet Scottish climate issues of moisture and condensation directly affecting the structure of those properties. So high-rise was the solution. It's difficult to imagine now just how much the west of Scotland embraced high-rise. Glasgow alone had 230 high-rise towers at its peak. So Greenock had 32 high-rise towers. In fact, that's on the next slide. The condition, the speed and rapid nature that these were built using those innovative post-war constructions such as the Wimpey's no fines concrete and their Paramount petitioning system meant that a lot of these structures weren't worth keeping ultimately, and many have failed. So that number 32 has now reduced to 13. But that 13 includes these three towers owned and managed by River Clyde Homes, our client. So Windhill Court, Prospecthill Court and Broomhill Court. Broomhill Court is focused on older residents, and there's more mixed families in Prospecthill Court and Windhill Court. I think there's around 10 families in Prospecthill Court. Interestingly, this photo's from the 1970s. We have residents in Prospecthill Court that have been there for 45 years. So they've not only seen some of the issues and the churn through these properties, they've also seen the previous retrofit, actually. They were built in 1970-ish, so right at the end of Greenock's high-rise boom. This was at a time when some cities were deciding actually high-rise maybe wasn't the way to go. They could start to see the social issues being aggravated by that detachment from the ground plane. Yeah, as I say, only 13 remain. Many have come down, including some really prominent and frankly hated buildings in Greenock. So yeah, as I say, we're retrofit number 2. In 2018, there was a retrofit of these three towers. Double glazing, EWI external wall insulation, that was a good thing, right? But unfortunately, within 3 years, failure. And these are the kind of headlines that no social housing provider or no funder of retrofit would ever want. The render had to be removed after failure because there was danger of things falling to the ground and hurting passers-by. So the whole building was effectively unclad and returned to a uninsulated state. Very difficult to get a project of the scale up and running. So the residents of Prospecthill Court spent 2 winters, 2 cold, Scottish, windy, damp winters without any insulation on their building at all. Not only was it uninsulated, but removal of the render left it in probably a worse state than it would have been in the 70s. You can see the adhesive that held the insulation on made it look literally scarred by its experience. But actually, removal of the insulation also revealed issues with the render. So there was direct water ingress through the failed render. You can just see the no-fines concrete there exposed. Those familiar to retrofit will also note that the window, the replacement double glazed window, wasn't in the insulation line actually. So this retrofit is likely to have generated its own damp and mold issues around the windows, I imagine. And that's something that River Clyde Homes will be considering because the other 2 towers still have the original retrofit. So what would River Clyde Homes do with this failed building? Well, it actually offers really good homes. A mixture of 1 and 2 bedroom flats. As I say, residents have been in this building for up to 45 years. We have residents that are housebound due to conditions and residents that rarely leave the building. The sense of community in there, though, is what really drives the retrofit project. There's another thing that drives the retrofit project, and that is the fact that the energy centre, which serves 600 homes, has flues rising up this building. So if this building was pulled to the ground, River Clyde Homes think it would cost around £20 million to replace those 90 flats, but they would still need a structure here to support the flues because those flues need to terminate at a height similar to those neighbouring towers. So River Clyde Homes put together a sort of design-led retrofit project. In many ways, this was treated like a traditional architectural project, actually. You can see BDP there as architects and doing some of the entry into the PHPP. Coda and Dr. Sarah Price will know much more about some of these slides than I do, frankly. They were a fantastic input as the retrofit consultant looking after the PHPP tool. Fairhurst engineers provided initial engineering advice. Nobody's going to go near a high-rise without some fire engineering advice and an understanding of how what we do impacts on fire safety in the building. Curry and Brown I should mention as project managers, but Kier as principal contractor, they've really done a good job. And I just want to highlight the role of tenant liaison there. That was an appointment that Kier got absolutely spot on. So I'm going to spend some time talking about that. They decided if you're going to do a retrofit twice, then the second time you do it right. So Duncan Smith, River Clyde Homes, Energy and Sustainability Manager, Duncan will be well known to you from the AECB, wanted to target the AECB carbon light retrofit, making us the largest carbon light retrofit in the UK, I'm told. So that means a space heating demand that's significantly better than the UK's existing housing stock, moving it somewhere between what you'd expect from a new build and a passive house style project. So 50 kilowatt hours per metre squared per annum, an air tightness target of 2, which I'm going to refer to later. We don't necessarily need heat recovery, although I'm sure would be good. We're going to use the Passivhaus planning package for our energy modelling. And at the end of the project, or during the project, we consider the other retrofit risks and produce a report to help the client understand those. Project value, 7.9 million, but 1.65 of that coming from the Scottish Government Social Housing Net Zero Heat Fund. Sarah's probably thinking that was a smaller number once. I'm afraid the Ukraine war and generally escalating prices has taken its toll on the project. We're not quite finished, but we'll be finished hopefully by the end of this month. Now, the next few slides, we're going to run through all of the things that were a challenge to the project. The list, I could probably just have done a full slide deck on this, but we'll just show you some of the key ones, because I think there are definitely lessons to be learned here. The first one is a lack of information. Riverclyde Homes knew very little about this building. So there was some fact-finding done by the design team and again by Kier when they were appointed. These were some archive drawings. We actually found that the archive drawings weren't as-built drawings either, so there was some hunting for no fines when we got on site. Yeah, post-war innovative materials. So we've got the no fines concrete. Is everyone familiar with no fines if they've come across it in a retrofit? So no fines is concrete without sand, without fines. That means this is the finished product. It looks like it just looks like a mess actually. So it's essentially a permeable concrete. In theory, at the time, it was considered a good thing because it's lighter than normal concrete. It will contain some air, but it's also permeable to water. This product was used generally on the outside of the building. So you had a traditional concrete frame. The section shows the no fines concrete forming the external wall, rising from the sort of toe at the edge of the slab there to the underside of that same toe above. So these photos show Kier essentially looking for the no fines concrete on some of the other walls. The reason they're looking for it is because they understand that it's going to affect air tightness. So we wanted to know how much the no fines concrete were we not impacting with the works. They also needed to know where it was because we wanted to fix things to the building. So Kier carried out intensive pull-out tests. The conclusion to those was that they really couldn't fix any new cladding rails, for example, to the no fines concrete, but it could take the weight of an insulation product fixed directly to it. That creates a little bit of a challenge because if you're going for a passive house type approach, trying to avoid cold bridging, you really don't want to be incorporating new structure outside of the building envelope. The other post-war innovative material is the paramount partition system. So if you can imagine those cheap internal doors you have in your house, like a corrugated cardboard with a veneer, this is a partition system which is essentially the same but using plasterboard. So around 6 centimetre thick partitions. And bizarrely, in my mind, the same partitioning system is used as a lining to the external wall. It just makes everything very difficult to work with. We weren't doing much to the internal partitions, but when we come to affect the external wall linings, everything becomes sort of problematic to work with. The structure within this is negligible. There's very little timber framing openings. The fact flues climb the building I've mentioned. Not only is this one of the drivers for the building's retrofit, but it also affects the air tightness of those 16 properties that happen to be on this corner, because unfortunately we can't move the flues to get behind the bracketry to improve the cladding. And so this whole area effectively becomes out of scope. That is a huge challenge. Riverclyde Homes, I should mention, do have huge ambitions for their energy network, and that's something that we could maybe, or Duncan Smith actually would be better placed to talk about another time. Another area that was largely excluded is the roof. Recent drone shot. So this is actually a drone shot taken of the completed retrofit. It looks terrible because essentially we haven't been able to do anything to the roof. The roof shows the energy centre flumes on the south elevation, shown here at the top, and a lot of telecoms infrastructure. The visibility of this tower within the region, within its sort of locality, means that it's an obvious location for telecoms infrastructure. We can't move it, we can't really touch it, so it's a really challenging environment. Luckily, this roof was upgraded when the earlier retrofit happened, so I know Sarah spent some time looking at as-built kind of drawings, trying to ascertain the performance of the roof and understand if we could leave it as was, and that is ultimately what we've done. Our technicians, as they looked at the previous, the performance of the building, also identified actually an issue with the ventilation to the lobbies and to the stairs. So louvers had been put in to ventilate smoke from the stairs in the event of a fire, but these were found to, essentially there's not enough free area in the louver, so we had to address this through the retrofit as well. And that's sort of sounding like scope creep, basically, but I think when it's fire safety related scope creep, you need to allow for that in your retrofit project, particularly in a building type like this. Allow for it and expect it. Now, pretty much everything you're seeing here is going to be removed. So I'm really just showing this just to show the quality of the construction that we found as we started to investigate the building. You're seeing the architraves have been removed to see foam basically being the thing that holds the PVC windows in. Bearing in mind these are 16 stories up on a windy coastal Scottish site. And I think that's actually a nail holding that bracket into the no fines concrete. This isn't the most reliable detail. This isn't a detail BDP would promote. You can also see the quality of the Paramount board system, which proved to be a bit of a headache for the contractor to work with. Kia really needed to find out what they were working with. We had an air permeability target, and so lots of air tightness tests were done on flats to understand the performance of the flats prior to retrofit. And some of those results were a little bit worrying, to be honest. Some air tightness, some tests have been done previously, which weren't quite as concerning this. I think this result may have been from one of those corner flats that's suffering through the support of the flue, which is to some degree penetrating the external wall. And worryingly, something we couldn't directly upgrade. The routes for air paths were, as expected, basically any hole through anything smoke was disappearing through. And tenants stay in place. This is the main success story, I believe, of this project. If we have to retrofit a nation, we have to do it in a way that people aren't displaced. I mean, if I look at Glasgow, my own city, the archetype approach is particularly fascinating because it's all tenements, right? So if we can find a solution for tenements, decarbonising tenements, keeping people in place, that's going to be a sort of easy win as the city moves towards a sort of net zero economy. As I say, Keir got a lot right with their appointment of their tenant liaison. They appointed an ex-River Clyde Homes housing officer. So she came to the project with that level of trust with the tenant. She knew around 60% of the people that were in the building. A dedicated role. Her attitude to the clients really reflected the attitude of Keir as an organisation, and that is they really considered to have 90 clients, not one. Tenants need to feel safe with the contractor in their homes. That's a quote directly from Kate. And I think every project needs to find a Kate, and I'm not sure how we do that, but her appointment was an absolute success story. She stayed in regular contact with the tenants, and she made sure the way the guys on site engaged with each flat was flexible. So a tenant might say, yeah, come on Monday, or Monday doesn't suit me now, I'm going to the dentist or whatever. They would have an alternative for something they could do that day. So it starts to remove program risk, starts to ensure that tenants feel that their needs are being accommodated, despite the solution to retrofit actually being identical for all 91 flats. The other genius thing they did was to create a pilot flat. So the pilot flat was originally created as a quality benchmark, so Keir could put in the Nordan triple glazed windows, resolve the new architraves. What the tenant liaison did was then furnish that flat from a local charity shop and make it available to tenants as a space for anything. So if the noise around their own property was their own flat was getting too noisy, they could come down and watch TV here instead. Uptake hasn't been huge, but it has been used for that purpose. A really good idea, and something I think we should consider in our own social housing retrofit projects. Because there is quite a lot of disruptive work inside the flats, despite this essentially being an overcladding project, we need to get into the flats to remove the old windows. So the new window is installed from the outside as part of the cladding system. I'll talk about that later. Unglazed, so the window frame goes in. So the contractor comes in, removes the old PVC window, then installs the triple glazing to the new window in its pod. He has to fix new sills, architraves, decorate around that window. And then we need to fix the ventilation because the air tightness barrier at the glazed window will reduce the ventilation. So a new extract vent is installed in the kitchen, connected to a humidistat. We need to undercut the internal doors to ensure we have a ventilation system through from the trickle vents in the windows to the extract fans in the bathroom and kitchen. And we need to look at the overheating risk as well. So Sarah had identified that because the energy network piped water at 82 degrees, high temperature, hot water being distributed through individual flats, I think up to about 8 meters of hot water pipework, essentially shedding heat into those properties all year round. So in the peak of summer, you really don't want it. So we've had to go into cupboards, ask tenants to empty their cupboards and insulate, essentially lag the pipes in the cupboards to reduce that risk. We also have to install an L1 smoke alarm system because we need all the new extract fans to turn off in the event of a fire. We don't want to feed the flames of the fire with mechanical extract. We also have the challenge of how to certify the building. So 2 approaches are possible, and it would have been Sarah that liaised with the AECB on this issue. We look at a whole building approach. That is definitely preferred. That would be the Passivhaus norm. One certification for one building fabric, essentially, for one PHPP tool, because that's really the thing that reflects the envelope that's losing the energy. There's no exemptions required because all flats would be within that envelope. It would test all parts of the building, so including common areas, the cladding that goes on lifts and things. It would also mean that that roof would be within that test. Unfortunately, it's really impossible to do because this is an inhabited building with 91 people, 90 people, well, actually 89 because we have the pilot flat and a concierge flat. So we've got nearly 90 occupied flats in this building. There's no way to do an air tightness test for a building that's being lived into that scale. So we can look at certifying flat by flat. That would probably mean exemptions because some of the flats in areas with large exposure to bits of building fabric that we're not touching might fail. Flats on the ground floor, for example. We'd also then need to look at the air tightness test and what we were testing. So if we're testing each flat on its own, that will also create its own challenges because we're only really upgrading the external fabric of the building, not party walls and walls to common areas or floors and soffits. So a kind of halfway house was agreed, essentially using almost like a kind of archetype solution in a way to test 10 mid-floor, sort of random mid-floor flats and a worst case scenario at the top and bottom, and that would achieve a single certificate ideally for the whole building. So what are we actually doing? Well, that's a sort of plan drawing of the condition of the building as we found it. You can see no insulation on the outside. This will be the no-fines concrete and a traditional concrete column, also hidden in the wall, the paramount wall board. So retrofit involves sorting out the air tightness with the membrane that needs to be sealed at the window. To seal at the window, we need to make some render repairs because we can't seal to the adhesive dabs, so there's a sort of harge coat almost around the windows to allow us to seal that. The window pod goes on unglazed. The insulation goes on, not that much insulation. Those looking at Enerfit and things will be used to, on smaller properties, will be used to seeing a lot more insulation than that. But we have a benefit of the size of the building helping to keep a relatively modest amount of insulation. And then the cladding system, effectively a commercial rain screen, aluminium rain screen cladding system. And then the triple glazing going into the window after the old window is removed. As I mentioned, no fines means no fix, really. So cladding rails had to be incorporated spanning between the small portion of traditional concrete that reaches the elevation at each floor and no fixings within the zone of no fines that meet the building envelope. So Coda's analysis of the heat loss through those cladding rails is quite revealing, and I think there's a lesson here for every project, because despite the cladding rails in red being a really tiny percentage of the actual total area of the facade system. Almost a third of the heat loss through that facade system can be attributed to the cladding bracketry rails and the fixings. That is a significant number, and it's something that starts to describe the performance gap that we know exists within our previous within the UK's retrofit projects. That's what the cladding rails look like as they go on. And again, the sort of retrofit aficionados will be saying, well, why wouldn't you put the membrane on first? That was the question I asked our technicians, and they had said, well, remember, we're 16 stories up. We've not wrapped the building in the scaffold. That membrane would be too exposed. So the solution was to put patches of membrane behind each bracket, and then you've got something reliable to tape to when you do gradually do the membrane panel at a time. Sarah's overheating diagrams, I've mentioned this already, the amount of pipework in the properties was assessed, and the amount of heat gain from those pipes was significant. Around 8 meters worth of pipe, as I mentioned, contributing a lot of heat to overheating. So we needed to address that. And ventilation. Ventilation is really important, and every retrofit project needs to engage with that, because having wrapped each property in this unbreathable skin, we needed to ensure we had a simple ventilation system. No heat recovery here, so we're relying on air coming in through trickle vents. You've got the air transfer through the undercut doors, and then relying on an existing extract to the roof from the bathroom. That's a permanent extract, and a new extract from the kitchen through the external wall. And of course, all these new penetrations need to be considered in detail as well. That extract is linked to a humidistat sensor to ensure that if there's activities in the kitchen, that those are addressed directly and that humidity doesn't come through the rest of the property. One of the best things the PHPP tool does is help educate those that use it, particularly people like myself that are fairly new to their Passivhaus qualification. There's a lovely diagram it produces for every project, and that's the energy balance. So over the course of a year, the property is essentially the same temperature at the end of the year to the start. So the heat losses through that property are the same as the heat gains. What the PHPP tool does is tell you, after you've entered all the data, what's contributing to those heat losses and what's contributing to those heat gains. We're finding more and more clients, for example, Edinburgh City Council, are now using the PHPP tool not just on Passivhaus projects, but as a design tool on all of their retrofit projects. And they're using it to come up with a very targeted solution for each typology. This diagram shows that we're below, the heating system is below the AECB target, but it also shows the obvious payoff, if you like, for not having the heat recovery system, because 50% of the heat lost from this building is actually through the ventilation system that we're promoting. So really interesting. I mean, the fact these are the heat you need to put in is almost equal to the heat loss through the ventilation is, to me, really, really interesting. In a new build Passivhaus project, we'd hope to get a better relationship between the heat loss through the windows, bearing in mind these are triple glazed windows. We're not in control of orientation, obviously, being an existing building, and so we're still getting more heat loss through that triple glazing than we are getting heat gain. Probably more things that people in the room used to looking at these diagrams will take from this energy balance than I am. So if you're spotting other things, I can highlight that to me. Window sequence, I kind of mentioned, you can see the parge coat to help. The window pod comes with tails attached to it, which are then sealed to that render repair around the window. The window pod is almost a proprietary system that D&B Facades, the facade subcontractor, was keen to use. From the inside, they look fantastic. The feedback we get from the tenants is that the deep sill created by pushing the window into the insulation zone, they think immediately gives them a really sort of robust sort of quality character from their properties. These properties were cheaply, thinly built, quickly built buildings, but somehow creating that additional depth on the external walls sort of creates that sense of quality that has sort of like a surprising benefit for many of the tenants. Being a high-rise, we need to consider safety risks. So where we're not moving any of the window sills, but we wanted to simplify the framing. So D&B facades have incorporated some bars to ensure we have the appropriate height. I want to engage a little bit with aesthetic. This was a drawing I did because at a point in time I was keen to explore the ability to use the building's overcladding to begin to improve its proportioning and how it looks. Architects can be a little bit obsessed with aesthetic. What we concluded in consultation with River Clyde Homes was that that was not appropriate here. Ultimately, because the neighbouring two towers were not going to be overclad, we want this building to look similar to the other two. And so the renders from our Revit model show we went for a colour palette that was essentially similar to the starting point, or not our starting point, but the neighbouring two properties. We're not quite finished, but that's photos taken by our photographer last week. So one of the neighbouring towers in the background, and our tower with its rain screen cladding. So you can see actually the building sits quite happily in its place because we haven't made it look significantly different. And I think that's something that has worked better than we imagined, actually. Another view of the tower in its place. I'd love to do the other two. Unfortunately, they're not failing as quickly as I would like them to. A little bit of a juxtaposition here between the stuff I like that's happening. The aluminium cladding looks great. We have taken the cladding off the enclosure that goes around the flues, has been removed. That will be redone in aluminium to match the building. The lack of work we've been able to do to the roof is it's a real shame, actually. There was even we wanted to at least render the lift motor room and overruns, but even that has been removed as a cost saving, so it's likely to get a coat of paint. The reason it was removed is because there's also telecoms infrastructure attached to just about every part of it that we can't touch. So the mass climbers are starting to come down now. You can see actually the issues that this building creates. The mass climbers themselves are still fixed into the building structure, so you don't ever get that clear sequence of trades where the air tightness is finished, then the insulation is finished, then the cladding goes on, right up until the last day. Practically, you're still trying to make the building airtight. And that can be a challenge for the airtightness testing, because the contractor can't retreat from site until he's got really good airtightness tests for each property, or for the one he's agreed to test. As I say, there's a few success stories for this project, and one of them is that it's better reflected in what the tenants have thought about it. So I've split their feedback into two slides. This is perhaps focused on their view of the specification. Now they can only see the triple glazed window going in, so they think most of their assessment is it's the window that's improved the quality of their flat, but actually it's the air tightness membrane, the level of detailing, and everything working together. Luckily, Duncan Smith, River Clyde Homes, has been looking at the data that's coming out of this building for a while now. So hopefully we'll be able to come back one day with a graph that shows performance before retrofit, performance with a shoddy retrofit, no retrofit, and our own AECB carbon light retrofit. And also, really to Kia's benefit, or to big them up a little bit, a view of the tenant's process. Some of the comments and feedback, such as this one, I find that really powerful, really moving, actually. And if we can find a way of retrofitting a nation and getting this level of support from people that need it most, that's what we should be aiming for. The fact people have lived through 2 retrofits as well, that's something everyone in this room would rather avoid, I'm sure. So to conclude, get to know your building. Don't wait for a design team to come along and say, can I have a set of CAD plans, please? Survey your building, make sure you understand what you've got. Figure out what the baseline is. It's never too early to do an air tightness test. If you can start to understand the mountain that you need to climb, then you can begin to de-risk the tender. If you can say to the contractor, actually, do you know what, air tightness is not too bad. So, well, okay, I might reflect that in my price. So you might start to steer some project certainty. The best sort of unsaid thing, I think, about Passivhaus and certainly the AECB carbon light standard is that everyone understands it's ambitious, but that ambitious targets do drive collaborative teams. Everyone has to work together to get certainly the air tightness working. Here dealt with this by using toolbox talk, so any tradesman that came on site had the same introduction to the standard, and there were discussions between BEST, for example, and the cladding supplier to ensure membranes were being installed in an appropriate way. And that was actually a dialogue. They actually had, well, no, we'll not do it like that. I don't want to be using a knife 16 stories up. I'll just fold it and tape it. So it's a two-way conversation. Every retrofit project, certainly when a tenant is in place, needs to be a process that is as much about people as it is property. There's financial value in making sure you're a people-focused retrofit. You're going to remove risk. If you're doing early consultation, you might reduce the number of refusals, making your whole process similar, effectively reducing the number of typologies that you're dealing with, reducing the amount of variety. Here's tenant liaison was amazing. How do we retain that knowledge with this project, and how do we build those soft skills? I think I'll be talking to BEST actually about creating the sort of how tenant liaison role and trying to define that. I think if we could get Kier's tenant liaison to contribute to that process and actually understand why it went so well, then that would be good. But also soft skills within the design team. There's a real risk that the design team disappear at the end of this project. How do we stay attached to every project and make sure we continue to learn? This is a personal concern for me. We've designed a system that relies on a ventilation system that has a starting point, which is an open trickle vent. These are really good quality windows. The storm guard windows shouldn't have whistling trickle vents and things, but there is a genuine risk that tenants simply close them all because they don't understand how their building's working. That won't happen with the current tenants because they've been briefed and they are really sort of on board. River Clyde Homes need to make sure the next tenant understands that as well. So there's a real education process that needs to be in. The retrofit will never end from that point of view. We need to make sure all future building users understand how the building works. And this is something I'll need to discuss with the AECB while I'm here, because ultimately we're not hitting the air tightness target for aiming for. And that is because of the flat by flat approach doesn't reflect the fact that this is a really shoddily built 1970s building. A flat by flat approach in a new build, not a problem. You could do your air tightness test for a flat, and because you're aiming for really good acoustics in the party wall, in the floor, in the roof, you'd get probably a relatively good proxy for your building performance from a flat. Here we're not, because there's too much within that envelope that we've not had an influence on, so we need to find a solution to that. And to end, I love this quote, carved into the Scottish Parliament: work as if you live in the early days of a better nation. Well, I think we need to retrofit as if we live in the early days of a better nation. Thank you.
Lovely. Thanks very much, Ed. That was absolutely fascinating. I'm sure there are loads of questions. We've got time for just a couple before we break for coffee. But Ed, you'll be on our panel later, I hope. And yeah, certainly. So we question time later. But I'll just take a couple at the moment. This gentleman.
Chris Twin. Excellent presentation, Ed. Brilliant stuff in there. My question is the use of PHPP. Excellent for analysing the outturns. Was it used for analysing the baseline of where you started? Because we're seeing issues of not being able to model how very easily how the people actually use the dwellings and the condition of the existing.
I think the answer is no. Sarah, would that be correct? No, so I'm pretty sure the answer is no. So our Glasgow studio has 4 Passivhaus certified designers now, and this was at the beginning of our Passivhaus and PHPP journey, and the first thing we did was to put in the geometry data that helped Coda complete the PHP model. I'm pretty sure the kind of outputs we were seeing were for the design solution. I don't recall using it as a baseline.
Just being careful that the impression of the level of energy savings come from, as you said, baseline.
We have lots of metering, so whether we've modelled it or not, we know literally Duncan will need to report to somebody, I'm sure, whether that Scottish Government money was well spent. it doesn't look cheap, does it? This is a lot of money being spent on one building. And I did include more slides. I do have slides about value, and I can maybe discuss them in the Q&A.
I was just wondering what the tenants have been told about. For instance, is it okay to close trickle vents on particularly windy days? Because I'm sort of thinking about with your internal air tightness issues, that when it's windy, surely you're just going to get the upwind side is going to get a howling draft into the trickle vents, and then it's going to go through and out the other side of the building.
Of course, they will close them occasionally. Our messaging and River Clyde Homes messaging needs to be simple. So it's generally try and keep the trickle vents open. Otherwise, your ventilation system kind of shuts off and you're driving a fan that isn't driving air. In reality, we know, as I know in my own home, trickle vents will get closed on windy days. We need to ensure they're opened the following day. Yeah, it's a concern. Actually, it's a genuine concern.
Hi, Pete Marsh. You shared the slide that was looking at the heat losses from the cladding rails. Was any thermal breaks considered on that or included when the cladding rails are actually attached?
Yes, so there were shims were considered. I can't remember if they were included in the end. There was an interesting interface between the cladding subcontractor and Kier, because in many projects the cladding subcontractor would act as a contractor, and they were used to that experience and had their own way of doing things. So it was quite an effort sometimes to influence that. It'd be interesting to know if anything we've done on this project influences their next project or their sort of standard system. One of the reasons for that is because everything, of course, is fire tested to the kind of nth degree. So Eagle-eyed might have spotted that we actually had another membrane on the outside of the insulation at a point in time, and that was removed because it wasn't practical in a 16-story on a site and 16 stories up, but also it wasn't in the fire test for the system that they had. So it's very difficult to change that system at all.
Just like to say thank you very much, Ed. That's absolutely brilliant. Thanks.